Hello and welcome to the module on univariate and bivariate analysis. By the end of this module, you would have understood what is statistical analysis, what is the purpose of doing such analysis, what are the different types of statistical analysis, what exactly is univariate analysis and what is bivariate analysis, and the difference between two types of analysis. Let us begin with understanding what is meant by statistical analysis. Analysis of data refers to the critical examination of the assembled and grouped data for studying the characteristics of the object under study and for determining the patterns of relationships between the variables relating to it. What is the purpose of doing such statistical analysis? Firstly, it summarizes the data into understandable and meaningful forms. Statistics makes the exact descriptions possible. The statistical analysis helps in identification of the causal factors underlying the complex phenomena. It also helps us in drawing of reliable inferences from the observed data. Lastly, statistical analysis also helps us in making estimations or generalizations from the result of sample surveys. Let us see what are the types of statistical analysis. The analysis may be broadly classified into two types, descriptive and inferential. Descriptive statistics describes the nature of an object under study. It may describe the data on one, two or more than two variables and is accordingly termed as univariate, bivariate and multivariate analysis. On the other hand, inferential statistics is concerned with drawing the inferences and conclusions from the findings of the research study. There are two areas of statistical inferences, that is the statistical estimation and the testing of hypothesis. The statistical analysis, as you can see in the figure, can be broadly divided into descriptive and inferential. Descriptive can be further classified as univariate, bivariate and multivariate, whereas inferential can be further bifurcated as estimation analysis and testing of hypothesis. Let us now see what exactly is univariate analysis. It is a method for analyzing the data on a single variable at a time, when we are observing only one aspect of the phenomenon at a time. With single variable data, we can put all our observations into a list of numbers. Answers to the statistical problems by collecting and analyzing data on only one variable at a time is known as univariate analysis. Such type of univariate analysis explores each variable in the data separately. Sometimes the data is collected to analyze just one variable. For example, if a researcher records the income of all the employed residents of a particular area and tabulates that data, it would just depict one variable, that is the income of employed people in that area. Now let us see how to represent and analyze such one variable data. This can be done using a frequency distribution. It shows you the number of times an event occurs within the topic which is being researched. For example, if one were to ask the students about the mode of transport they take to come to college, and if the answers can be tabulated as given in the table, that is students' mode of transport to college along with the frequency. The mode of transport could be train, bus, bike, walking and so on. Accordingly, the numbers which you see in the frequency column are nothing but the actual number of students who use the corresponding mode of transport to travel to college. The second way of representing univariate data is using a graph. Graphs enhance the utility of the univariate analysis by providing visual representation of the distribution of that particular variable. There are different types of graphical analysis. The most commonly used is the histogram. Histogram is nothing but a bar diagram which conveys the relationship of one group or class of variable with the other variables. For example, income earned, which is represented on the y axis in lakhs of rupees, and the types of grain sown represented on the x axis in 4 states of India, can be taken as an example of histogram. The second graphical way of representing the data is using a frequency polygon. This is nothing but a graphical diagram displaying the area under the curve, which is represented by the values that variable takes. This type of chart is usually used to show time series graphs or the changes in rates over a period of time. The third way of representing the univariate data is using a pie diagram or a pie chart. In a pie chart, each slice of the pie represents the proportion of the total phenomenon, that is due to each of the classes or groups. For example, in the diagram across, you can see the sales revenue in a year for the 4 quarters in a particular company. Another way of representing the univariate data or analysis is through the measures of central tendency. These are commonly used for describing the center of a frequency distribution. The measures of central tendency include the mean, the median and the mode. The most common measure of central tendency is the average or the mean. The median, on the other hand, is the centermost value when the measurements are ordered according to their magnitudes, whereas mode is the value which occurs most frequently in your sample. The univariate analysis can also be used in the form of spread of the data. This can be done using the measures of variability or dispersion, which summarize a single number by providing important information about its spread or distribution. Range is most commonly used, which is nothing but the distance separating the lowest and the highest value. In other words, it is the difference between the minimum and the maximum value in your data. Skewness and kurtosis are other measures of dispersion which may be used. Skewness is nothing but lack of symmetry in your data, while kurtosis is nothing but sharpness of the peak of the frequency distribution. Standard deviation is also a very commonly used measure which tells us how much is the spread of the data. Now let us go to bivariate analysis. Often researchers are interested in gathering information not about just one variable, but more than one variables. For example, in a study on educational level of population, researcher also obtains data on other variables like age, sex, family income, distance of educational institutions, etc. When we consider only 2 variables at a time, we are actually studying bivariate data. In bivariate data, 2 values are recorded for each observation. For example, if we see the data on income and weight of individuals, so one column of your table would give you the income of the respondent in thousands of rupees, which may be termed as variable Y, and in the other column you will have the corresponding values of the weights in kilograms, which may be taken as a variable X. So these are 2 values for the same individual, his income as well as his weight. Such type of data is known as bivariate data. There are two important characteristics of the data which is revealed in this table. We can clearly see that the variable y, that is the income, increases. Simultaneously, the second variable weight x also increases. If we graph these two data, we will see that the points cluster along a straight line. When this occurs, the relationship between two variables is known as linear relationship. Now, let us see what are the usual types of variables which occur in our data. Let us start with the nominal variables. Nominal variables can be referred to as a set of categories that vary only in quality but not quantity. There is no order, distance or origin between such attributes or variables. For example, gender, male, female, race, white, black, Asian are examples of nominal variables. Now, let us go to ordinal variables. Here, the distance between the values of the variables do not have a precise numerical meaning. The distance between the categories is not known. The variables, however, are ranked on certain characteristics or attributes of the objects, and we only know the order of these categories. For example, when we usually have the contest winners, we place them at the first place, second place, third place, etc. Now, what are interval variables? Interval variables include those variables whose attributes are not only ranked or ordered, but also separated by a uniform distance between them. The numbers associated with interval variables usually have real meaning. Such measures have an arbitrary 0 point and a constant unit of measurement. The mathematical operations like addition, subtraction and calculation of mean or average are possible with such type of interval data. The examples of interval variables include age, income, city population, weight, height, etc. On the other hand, ratio measures are the same as interval measures, except that they are based on a true 0 point. For example, age. All statistical operations can be performed on ratio measures. The different type of variables and the type of inferential statistics could be summarized as given here. If we see the nominal variables like gender, we can compare their distributions using central tendency. If we have ordinal variables like the class grades, we can go for crosstabs or measures of association to infer about their analysis. Lastly, if we have ratio or interval variable, that is the age, income, etc., we can very well use regression analysis to infer about such data. Now, let us see what is association. With bivariate analysis, we are actually testing the hypothesis of association between the two variables and the causality. Association is useful as it can be very well used to predict the value of the dependent variable once we know the value of the independent variable. The measure of association which is very commonly used is known as the correlation coefficient. It often ranges between -1 and +1. The sign represents the direction of the correlation. If the coefficient is negative, it implies negative association between the two variables, whereas if the coefficient is positive, it implies positive association between the two variables. Now, how do you compare two nominal variables? Often, we need to compare two nominal variables. For that, we very well can use the measures of central tendency. On the other hand, if we have to compare ordinal variables, then the measures of association attempts to measure how the values of the ordered variables actually relate to each other. Most analysis here begins with a simple cross tabulation. If we consider a hypothetical data about education being important to improve one's status, our contingency table would look like gender, male, female, and they give out answers yes, no and not sure. So, if this information is tabulated as shown in the table clearly shows that the female respondents in our sample consider education being very important to improve one's status. If we want to compare two ratio variables, then regression analysis can be very well used to measure the degree of relationship between two or more ratio variables. In regression analysis, the dependent variable is generally denoted by the capital alphabet Y, whereas the independent variable is usually denoted by the capital alphabet X. If we want to compare interval variables, one statistic which is often used is the t-test. This statistical test is used to check whether two subgroups of a sample have large enough difference between their means. In other words, the difference between their means actually exists and is statistically significant. The module on t-test will clarify this comparison aspect. Let us quickly have a comparative look at the univariate and the bivariate data. Univariate data involves a single variable, whereas bivariate data involves two variables at a time. Univariate data does not deal with causes or relationships. On the other hand, bivariate data usually deals with causal or relationships data. Univariate data, the main purpose of univariate data is to describe. On the other hand, the main purpose of bivariate data or analysis is to explain. The analysis of univariate data can be done using the measures of central tendency like the mean, median, mode, measures of dispersion like the range, variance, quartiles, standard deviation, etc., using frequency distributions, and also can be done using graphs like bar graphs, histograms, pie charts, line graphs, box and whisker plots, etc. Whereas, in bivariate data, the analysis is done using correlations, comparisons, relationships, explanations and tabular analysis, where one variable is contingent on the values of the other variable. Here we have the concept of the independent and the dependent variable. Let us summarize the entire module. Statistical analysis of data refers to the critical examination of the assembled and grouped data for studying the characteristics of the object under study and for determining the patterns of relationships among the variables. The analysis summarizes the data into understandable and meaningful forms and also helps us in identification of the causal factors underlying the complex phenomena. It also helps us in making estimations or generalizations using the results of sample surveys. The statistical analysis may be broadly classified into descriptive and inferential statistics. Descriptive statistics describes the nature of an object under study, whereas inferential statistics is concerned more with drawing inferences and conclusions from the findings of the study. Answers to statistical problems by collecting and analyzing data on only one variable at a time is known as univariate analysis. When we consider two variables at a time, we are looking at bivariate data. With bivariate analysis, remember we are testing hypothesis of association and causality. Hope this session has given you a good idea about the concepts of univariate as well as bivariate statistical analysis. Thank you.